Okay, guys, so now the one theorem that we're going to look at right now that's left over is angle, side, angle. So we did side, 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 angle, side, and now this third one is angle, side, angle. So if two angles and the included side of one triangle are congruent to two angles and an included side of another triangle, then the two triangles we can say are now congruent to each other. So it's exactly how this picture looks. You have the two angles and a side in between in both triangles. Okay, so again, you're still figuring out three things that are congruent about the two triangles. You just need two pairs of angles and one side that would be in between them. So to just fill in this little piece here, if we're talking about an angle, we would have angle A is congruent to angle D. The side that we have is AB is congruent to DE. And then that second angle is angle B is congruent to angle E. Okay, so if we have the two pairs of angles and the side in between, then we can say that triangle ABC is congruent to triangle DEF by ASA, angle, side, angle. Okay. So if you need to pause that, you can pause that right now to make sure you have this copy down. If not, you can continue onward. We're going to take a look at some proofs. So this one, we have all the statements filled in for us. We're filling in all the reasons. Again, like usual, we're going to make our checklist. Okay, we need the three things congruent about these two triangles to be able to say that they're congruent themselves. We're given only one piece of information here. We know that SQ bisects angle RQT and at RST. So RQT is this angle here, and RST is this angle here. Okay, so the first thing we have is given information, right? Our first statement is essentially what we just were given. So our reason is given. And then we're told that angle RQS, so RQS is this angle here, that's congruent to TQS. So that's a pair of angles. Okay, and that's based off of the definition of an angle bisector. So we use the word bisect here to be able to figure that out, but an angle is being bisected, so that means SQ is the angle bisector. So we're going to say that our reason for number 2 is definition of angle bisector. Okay, so SQ is an angle bisector here because it's bisecting an angle. Okay, so that's what we're using as our definition. Similar situation, we know that RSQ, so this is our second pair of angles, is congruent to TSQ. So again, that's the same thing. We have another pair of angles here, and it's again definition of angle bisector. Okay. And then now we pretty much exhausted everything that we know about SQ bisecting those two angles. So there's nothing else we can pull from it. So we're in a when in doubt, look for either something reflexive or for vertical angles. Here we have something reflexive. QS is a side that's shared between the two triangles, so it's congruent to itself. So we have a side here. Okay. Our reason for that is the reflexive property. Okay, again, the reflexive property is just saying that a side is congruent to itself, right? So it's shared between the two triangles, and marking that, you put an X on it. So our checklist is full. Our checklist is saying that we have angle, angle, side, but you go based off of the picture. So if the picture looks like it's a lot, sketch out one of those triangles, and we have the two angles and the side in between. So it is actually angle, side, angle. So our checklist isn't always going to tell you that the theorem is exactly how it should be. You have to go based off of what the picture is showing you. Our checklist is simply telling us that we have two angles and a side, and then we have the three congruent statements already completed. So now we can say the triangles are congruent, but we got to just make sure that we're writing it in the right order so that we have angle, side, angle. Okay. So that's the first question there. Let's scoot to the next one. So again, we have our statements filled in and we're given reasons. So looking at what we have two statements here, 1 and 2. They actually put them all into the first statement, right? So we have the two givens and it's all in one statement there. So just for number 1, that's our given. Okay. And let's mark it up on the picture. So we know JK is parallel to LM. Again, the parallel symbol is that little arrow on the line. And then we also know JL is parallel to KN. Okay. When we're working with parallel lines, we're going to have one of two things. We're either going to have corresponding angles or alternate interior angles. Okay. So we have to figure out which ones we have. Corresponding angles is if they are just in the same placement, one on each parallel line. Alternate interior angles is if they're between the parallel lines and they're one on opposite sides of the transversal. So let's just take a look and see what we have based off of what we're given as a statement. We have JKL and we also have MLK. That is alternate interior angles. So we're going to say alternate interior angles congruent. And then we also have JLK with MKL. And that's another pair of alternate interior angles. Congruent. So we have two angles for our checklist. We need one more thing. Looking at this, again, we're going to, when in doubt, look for either something reflexive or for vertical angles. We have a reflexive side here. Side LK or KL is congruent to itself here. So that is the reflexive property. The two triangles share that. So that's our side. Okay, and then our checklist is full. Again, our checklist is telling us we have angle, angle, side. But if we just separate out one of those triangles, we do see that we have angle, side, angle here. So angle, side, angle is our reason for that last statement. Okay, so that is number 2. Then we've got 3, and then this last piece actually we're skipping. So if you guys want to go ahead, you can just write skip on this. We're not going to work on this yet. Okay, we are going to take a look at just this third proof, and then that's it for the angle, side, angle notes. So let's take a look. We have everything completely blank, so we are going to be filling in all this information right now. We have angle BAC is congruent to angle DEC, and then we also have C is the midpoint of AE. I'm going to write down my checklist. So my first statement, again, your first statements are always what you're given. So we have angle BAC is congruent to angle DEC. That's given. I'm going to mark that on the picture. We have BAC, that's this angle here. It's congruent to DEC, that's right there. So that's an angle. Next one we have is C is the midpoint of AE. That's also given. Okay, so statement number 1, we already did that. That's done. We can't pull anything else from it. C is the midpoint of AE. We can pull information from that. So if C is the midpoint of AE, okay, that means that it's splitting AE into 2 equal pieces. So if C is the middle of that, that means A to C and E to C would be the same measure, splitting it perfectly in half. So for 3, we're going to say AC is congruent to EC. That's a pair of sides there. And that would be definition of midpoint. We used what we know about a midpoint to be able to say that those two pieces are congruent. Now I exhausted everything that I was given, and I now have to think about, is there something reflexive there, or do I have vertical angles? So there isn't a side that both of these triangles are sharing at all. They share point C, but that's not a side. That's just a point. So we can't say there's anything reflexive, but we do have a bow tie situation here where we are going to have these two angles congruent to each other. So we do have a pair of angles. I'm going to fill that in my checklist. An easy shortcut here, instead of marking out the letters like saying angle BCA and DCE, sometimes it's easier to just mark a 1 and a 2 in there. And then we can just say angle 1 is congruent to angle 2. And then that would just be vertical angles congruent. Okay. So marking the 1 and 2 is just a way to make it easier to write down the angles. But you can only say 1 and 2 if you mark it up on the picture. If you don't mark it up on the diagram, then you cannot write down just angles 1 and 2 and then have it not written on the diagram. Then we don't know what angles you're actually talking about. So this is why it's really important to make sure that you are marking up your diagram there. So I have my checklist completely filled. If I look at the triangles, they're nicely separated here, so it's easy to see that we have an angle, a side, and then an angle. So I am using angle, side, angle to show that these two triangles are congruent. So I'm just rewriting what my proof statement is in the last step. Okay, and then that's it. That's that proof. So that should be the end of the notes for you guys for today. Again, we're not doing the angle side yet. We're going to do that later on in the unit. We're going to just focus on the 3 that we did so far so you guys get nice and comfortable with that. If there's anything else that I assigned, please make sure that you check Google Classroom with that. I do have some practice questions on Delta Math that I'm going to be giving to you guys. Okay, so just please make sure you follow that along. And that's it.